Once the general requirements and the data sheets have been defined, typically the next step in the process is to describe the logic by which the safety function activates. There are numerous different ways to describe logic, ranging from textual narratives to binary logic diagrams, but the most used, most compact, easiest to follow is going to be the cause and effect diagram, which is also the most popular. Now, in Vertigo, you access the cause and effect diagram page by clicking on the C&E diagram button in the navigation bar. And when you do, it doesn't automatically bring up a single cause and effect diagram because there can be many, many different cause and effect diagrams associated with a single project. So the way that Vertigo works is we go back to that IPF group, and it will generate one cause and effect diagram per IPF group. And again, you can define your IPF groups based on major pieces of equipment or plant sections or plants as a whole, however you decide you want to do it. So I'm going to select the first IPF group, which I called USC 101, that was associated with the high pressure separator. And when I select it, you'll see that the cause and effect diagram was created. Well, we didn't need to actually do anything to create this cause and effect diagram. It's actually automatically generated. And what the software does is it will collect all of the sensors that are associated with USC 101 and all of the final elements that are associated with USC 101. Well, you ask yourself, well, where were they associated? And that goes back to the datasheet pages. When you look at the datasheet pages, for instance, on sensor, you'll see that one of the items that you can select is which IPF group is that instrument associated with, and we selected USC 101. And the same thing is true of final elements. When you pull up a data sheet, you'll see that IPF group is one of the items that you can select. So all that the software did was collect all of that information together and then build a grid. And in that grid, you can fill in the intersections however you would like to fill the intersections in. So you can do something as simple as just an X indicating this input causes this output to fire. You can use codes like CLS for close or OP for open. And another thing that we recommend, kind of a best practice, is if an intersection is more complex than simply this input fires that output, you might want to describe it in a note. And those notes, again, go into that general requirements section. In this case, it would be a specific requirement, but a requirement nonetheless. So in this case, I know that LT101B causes shutdown valve 101AB to close, but there's some more complex logic. Maybe it's a time delay functionality, or there are a lot of different things that can go into defining the logic that causes inputs to trigger outputs. And the notes are a good place to document that, and in the cause and effect diagram you simply insert a reference to where that note is. So that's how we like to document the logic. That's what happens in Vertigo. And as I mentioned, there is a page for each interlock group that you define, and you can define as many as you want, or you can collect everything into a single group.